evaluate this limit x raised to 9 plus 1 all over x cubed plus 1 as x approaches to negative 1. If we simply plug in x equals negative 1 here, negative 1 raised to 9, that's negative 1 plus 1, 0. Negative 1 cube is negative 1 plus 1, 0. So we get 0 over 0. That means when we graph this function at x equals negative 1, there is a hole on the graph. Limit still exists, so we need to do more work. What we can do here is we can factor the top, factor the bottom, and cross out zero making factor, but the factoring is not easy. So now we have new tool called L'Hopital's rule. We can use the L'Hopital's rule. Okay, whenever we have 0 over 0 or plus minus infinity over plus minus infinity, plus or minus infinity, or like that, then we can use L'Hopital's rule. So I'm indicating that, writing LH, which is the limit of this fraction is same as the limit of the derivatives, fraction of their derivatives. So we find the derivative of top on the top, derivative of bottom on the bottom, which is 9x8 from the power rule, plus derivative of 1 is 0, plus 0 does not count. Similarly 3x squared. Okay, I found the derivative of top on the top, derivative of bottom on the bottom. Let's simplify before we try to plug in. So 8 copies of x, 2, so we can cancel 2, that leaves 6 copies on the top. So this is in fact limit x approaches to negative 1 of 9x 6 copies over 3. Oh, we could have cancelled 3 and 9 as well. Yeah, 3 goes 3 once, goes 3 times. Now we can simply plug in x equals negative 1 because we are not gonna get 0 over 0 anymore. There is no 0 on the bottom. If it happens, if we still get 0 over 0, then we just repeat L'Hopital's rule one more time, or many more as needed. So in this case, there is no 0 on the bottom, just 1 left. So this is 3 times x is now negative 1 raised to 6 all over 1. Don't have to put 1. Negative 1 raised to 6, negative 1, negative 1, negative 1, multiply 6 times, it's gonna be positive 1, times 3 is 3, over 1 is just 3. So the final answer is 3.